is that it's like the iPod, but it's different than the iPod. It's like the iPod because it is a goodness of fit test. So you're still checking. It's still a goodness of fit test, which means you're testing a distribution and you're seeing how well data fits to it. Yay, it's that. How is it slightly different, though, than the iPod? Here's what I'm going to write down. I'm going to put down what we saw on Wednesday. And we've got percentages, right? We've got red, we've got brown, we've got yellow. This is just for reference over here. This is not part of the data. It's just keeping our data straight. Yellow, green, orange, and blue. Here's what we saw on Wednesday. Thank you, Kate. Here's what we saw on Wednesday. We saw red. We saw 80. Brown, we saw 219. Yellow, we saw 177. This is not percentage. This is just, these are raw counts of the data, just like the raw song shakes on the iPod. Green, we saw, oh, 335.
Yeah.
Orange, we saw 219, just like brown up here. And that's kind of cool, actually. And blue, we saw 167. With a sum total of 1,197 candies if Excel is adding correctly. So just shy of 1,200 candies. So this is like, at this point, on Wednesday, when Sarah was shaking the iPhone for me, and we were keeping track of the songs that we saw, we shook until we saw 50. Shook until we saw 50. And we got our observes. So far it looks just like the iPod. It's just like the iPod problem. So how is it different?
Without replacement.
Say that again.
It's without replacement.
Oh, thank you, Renee. Can we treat it as though it were with replacement? This is good. This is very good. I wasn't going for the independent argument, but that's a good one.
Is it?
It's not really independent, just like Max really wasn't with replacement putting the chicks.
I was going to say, did you say with a big enough sample that it's basically with replacement?
There are so many M&M's candies made every given year, every given month, every given week that we are essentially sampling with replacement, which means we can treat it independently. Thank you. That's good though. You have to be able to at least analyze that, because if you can't do this. You use a hypergeometric distribution, which I love it, but you don't have to. Yeah.
The expectations are different.
Exactly. The expected values you're going to get are going to be different for each color. Whereas on the iPod, they were all the same because we should have seen 10%, one song, 10%, 10%, 10%, 10%. So in other words, thank you, Deanna, it's exactly right. That's what makes it slightly different, is how you construct your expectation. Your expectation for red should have been 13%. Now the problem right here is we got apples, oranges. We got apples, we got oranges. We can't go apples, oranges, go apples, apples. So how do we turn 13% into 13% of 1197? That's how we turn it. Of the sample that we got, 1,197, we should have had 13%, which according to Excel is 155.61. That's how many red we should have seen. Which, if you look, compare that to that, it's about twice as much. We made a claim. We saw about half as many red as we should have seen. Well, that's because that's how many we should have seen. It's okay to put 0.61 because it's 155.61 on average. M&M's on average. You can totally average 0.61 of an M&M.
Yes. 2/3 of a girl.
Exactly. 2/3 of a girl, or whatever it is. 0.4 of a girl. Exactly. Exactly. Browns, I think, are the same, right? Browns are also 13%. Which means we should have seen 155.61 browns. We actually saw 219. So we were under with the red, we're over with the brown as far as those percentages go. As far as those percentages go. Go so far? Yellow should have been 14%. And that gives us 167.58.
Not too long.
No, and yellow we weren't upset with. Yellow was 14 versus 15, and we were like, I can live with that. That's damn close to what it should be. 10 candies is not the biggest deviation. Green is 16% of the overriding total, which brings us to, we should have get 191.5, 191.52, where we saw 335. This is a bit of a deviant deviance there. It's a bit of a deviance. That's the problem. And you're starting to see now how we use technology to do this. This is a royal pain behind. With the iPod, it was easy, and I had to set up the iPod to be easy. 50 shakes, 10 songs, everything ends up being 0.2. These are horrible, that's why I'm using Excel to do it. Orange should have been 20% of 1197, which gives us 239.4, thank you. And last but not least, 24% should have been blue. 287.28. Yeah. And it looks like Excel added everything up correctly, because the last number is a 0, yay. So I'm going to guess that the sum of this is also 1197. Assuming that Excel did all its math right. Looks like it did. I have a little sum command underneath it. So. Fair enough? So that's what we saw. That's what we should have seen. The question is what we saw versus what we should have seen close enough to calm our guts? And that's where we fall short as humans. We can't measure this. I mean, there's no way to measure this, especially when you have more. With one proportion, it's usually not that big of a deal. With two, it gets a little, with a 6, it gets too hard. That's where we rely on technology to do it for us and interpret. So, let's rely on technology. Grab your TI. My pocket is broken. How many times? My left pocket. It falls out. Let me get technology 2. Use either the program I gave you or the one that's built into your machines. That's fine too, because it gives you a graph. I'm going to pull up the chi-square graph here in a minute. Because even though the TI gives you a graph, which is awesome, and one of these days I'm going to rewrite mine so it has a graph. Excel's graph is going to be nicer because it's color, first of all. I know.
Excuse me.
I know. It's thrilling.
That time's gonna kill him.
I wish we'd stop at the daylight savings time. I mean, I understand the point, but if it would make more sensible changes, like changing all our light bulbs to LEDs, it'd save a lot more
It's
power.
George Bush's fault that we
No,
had
it's
that.
not.
Yes, it is. Yes, it
No,
is.
it's not.
He signed the law, the 2005
He
Energy
didn't create
Protection
daylight
Act.
savings
He-
time.
No.
I'm not a Bush supporter, but I'm not going to blame Bush for daylight savings time. Blame Ben
but a
Franklin's
month,
history
but
and
a month
idea.
earlier. No, I know that's for a fact.
Tim,
I'm schooling you on
Tim,
this.
I'm not going to blame W for something he didn't invent in the first place.
Okay, no.
That's like blaming a coach when his team loses.
Part of the 2005 Energy Protection Act was to extend daylight savings time by a month.
I'm not doubting that.
Yeah.
I'm also not. That
He
doesn't
didn't-
imply that Bush is guilty
he
of
didn't
coming.
invent
Shut
it.
up
He
with
just
the
extended it.
I'm done. I'm done with it.
Otherwise, it would have been an early April.
Don't move to Arizona. They don't have it.
That's true. They don't. That's right. They don't.
So I can fix your problem.
And they don't have a time change. Correct? There's no time zone. I think it skirts around them. I guess.
Yeah.
Very clever. All right. Let's get in here. The first thing you have to do before you run your program, though, is put your data in. That's one thing I forgot last time doing the iPod data. So you got to get your data in. So L1's going to be, I put observes in L1. That's 80, 219, 177, 35, 219, and 167. L2 is everything expected, 155, 161, 161, 167.58, 491.52, 239.4, and 287.28. That's all you got to do. I know last week I crunched it through the iPod randomizer and we did it together. That's the only time you'll ever have to do that in your lives, I promise you. Well, I take that back. You may have to take 367 and know what shit. They might make you do it again manually. But that's okay. You got the template for it. You know how to do it now. You'll probably forget between now and then, won't you? That's okay too. That's okay too. You'll relearn. So now you just run the program. It does everything for you. So program or stat test, whatever you want to do, up to you guys. GOF, for goodness, fit. It then asks you where your lists are. Tell it. L1 is my observed. L2 is my expected. Press enter.
What's the
Degrees of freedom. Who asked me that? Great question.
1 minus?
Who asked me that? Great question. Sarah, thank you. Degrees of freedom is a, we're gonna get back into that today actually. Degrees of freedom is one of those great terms from statistics that talks about which curve you're graphing on. The number of degrees of freedom is the only thing that changes this chi-square curve. The normal curve didn't have these, so you don't have to worry about it. For a goodness of fit test, it's one less than how many categories you have, so it'll be 5 in this case. I don't understand why the TI doesn't just look at your data like mine does and count. It's got 6 things, use 1 less.
It says 5 in there, so.
Oh, it actually put it in.
I think it put it in there.
Oh, maybe. That's good. Maybe it sensed it. Yay.
I did it.
It did not. Okay. Boo. Once we get boo that quick.
How do you do this? You go to programs and GF
Yep.
and then.
That's it. Then just tell it where your data is. Observed and expected. List 1, list 2.
But it's
Done.
not doing that.
Press enter.
Okay.
And then just say observed question mark. Okay, then I gotta fix your program. It's corrupted. Yeah, network. Blank. Now the question is, what does this mean? 222.67. I know you're used to thinking that as standard deviations, but it's not. It's a marker. It's a marker. But do you remember the smallest value this could be theoretically?
0.
Thank you, Andre. 0. 0's the smallest. 222 seems like it's pretty far away, doesn't it? Now here's where I like having the graph, and I haven't written if you're running the TI's version, it actually will show you the graph. I want to pull back to Excel, because Excel, I have the graph built into Excel. Whoops.
It says p-value equals 1 though.
1?
And that one says 0.
Well, it should be 0. 1? Yours says 1? Oh, Scott, I need to take a look at that. It should not be 1. Holy hell. I want to come back to that too.